Today we are going to determine validity of arguments by applying tautologies or logical equivalence. Okay, let's go to our PowerPoint presentation. Determine whether each of the following arguments is valid or not. If valid, give a two-column proof. Okay, let's go to our blackboard. Okay, I have here a list of tautologies, so and their names. You have here idempotent loss, double negation, commutative loss, and then you have implication, contrapositive, and so on. In ordinary language, when you say that a statement is a tautology or logical equivalent, they mean the same thing. So for instance, P implies Q if and only if not Q implies not P, or if P then Q if and only if not Q then not P. In ordinary language, they mean the same thing. Another example, if you have here if P then Q, it's the same as saying not P or Q. So that is in ordinary language. But in the parlance of logic, you call them as logical equivalent, or they are called tautologies. So let's go to our first example. So you have here the premises. Okay, so you have here the premises, and then you have the conclusion. So our goal is to determine whether this whole argument is valid or not. Okay, so let's give a two-column proof. So that this is the traditional way of proving. So you have a statement and reason. Okay, so let's start with the premises first. Okay, so let's start with the first statement. So let's have the negation of M or T. So this is called the premise. Our reason is this is given or premise. Second statement, we can write M if M then T. Our reason is implication. Implication. Okay. So let's just try to abbreviate. This is from statement 1. Okay, let's see implication. So implication says that P implies Q is logically equivalent to not P or Q. So not M or T is logically equivalent to M implies T. Okay, third statement, you have T implies not D. So again, this is premise. Okay, let's have the fourth statement. M implies the negation of D. So from statement 2 and 3, if M implies T and T implies the negation of D, therefore M implies the negation of D. Our reason is hypothetical syllogism from statement 2 and 3. Okay, so let's try to check hypothetical syllogism. If P implies Q and Q implies R, therefore P implies R. Okay, item 21 is also referred to as transitivity. Okay, so let's proceed. E implies D. So this is again premise. Okay, let's go to our sixth statement. The negation of D implies the negation of E. So this is actually called contrapositive. So this is from the previous statement 5. So let's check contrapositive. Okay, so P implies Q if and only if not Q implies not P. So these two are logically equivalent, or this whole statement is a tautology. So you have E implies D, or if E then D, it's the same as saying if the negation if not D then not E, or the negation of D implies the negation of E. So that's contrapositive. Number 7, you have statement number 7. We can have E implies the negation of E. So this is actually hypothetical syllogism also. If you check statement 4 and statement 6, okay, you have M implies the negation of D, and negation of D implies the negation of E, therefore M implies the negation of E. So let's check again contrapositive. Sorry, hypothetical syllogism. If P implies Q and Q implies R, therefore P implies R. Okay, let's have the eighth statement, E or G. This is premise. Let's have the ninth statement, negation of E implies G. This is actually implication again from line number 8. Okay, so E or G is logically equivalent to if the negation of E implies G. And then our 10th statement, E implies G. This is actually called hypothetical syllogism from, if you check statement 7 and statement 9, you have M implies the negation of E, and the negation of E implies G, therefore M implies G. So if you notice, in the first item, our conclusion is G implies M. It seems that when we have our proof, the conclusion should have been M implies G, and this argument is not a valid argument because G implies M is not logically equivalent to M implies G. You call this actually as converse statement. So they are converse. G implies M is the converse of M implies G and vice versa. They are not actually tautology or logical equivalence. So the correct conclusion is this second item, M implies G.